Hello everyone, this is Junaid here from Edureka and I welcome you all to this interesting session where we are going to turn any image that we give into a cartoons. So without any further ado, let me quickly walk you through today's agenda. We'll start this session by understanding the problem statement and what exactly would be its workflow. Following that, I'll be walking you through the different tools and frameworks that we are going to use, and finally we'll start building up this project. Alright, so before we begin, do consider subscribing to our YouTube channel and hit the bell icon to stay updated on trending technologies. And also, if you're looking forward for Python training certification, please check out the link given in the description box below. Alright guys, coming back to our project, right? So what exactly are we going to do here? Well, you see, you might have heard of these filters, right? Like anything on Snapchat, or we also have this PixArt, wherein we provide any input image and we get this edges, and it's something we are trying to cartoonify the image. So similar thing is what we're going to do here using Python, and the library that I'm going to use over here is going to be OpenCV. Alright. So there are a couple of steps that we are going to follow. That is going to be, first off, load our image, then create an edge mask, then we got to reduce the noise and all, so on and so forth. So let's now move ahead and see what would be its the workflow. Okay, first off, what we are going to do over here is load our image. So the image can be any image. I would say it's better to take an image of a human, and then what we're going to do is we're going to create a mask followed by reduction of noise. Moving ahead, then what we're going to do is reduce the color palette. Over here, what does this color palette mean is, let's say I just want to create a cartoon which has only 4 number of colors, right? So this is what we're going to do. And finally, we are going to combine our edge mask and color palette in order to create a cartoon of any given image over here. So what are the different tools and frameworks that we are going to use? So to start off, what we are going to do is we are going to use Jupyter Notebook. All right. And the major library or the important library that we are going to use over here is going to be OpenCV2. All right. And then, as we all know, a couple of standard libraries that we're going to have is matplotlib and numpy. And before you move ahead, guys, the knowledge on Python is pretty essential here. And if you're someone who is totally new to Python, please check out the Python full course link, which would be given in the description box below. So now that we know a bit about what's going to happen and what we are going to work on, let me quickly jump to my code editor and show you how we can build this interesting project. All right, so here we are. This is my Visual Studio Code. All right. And now what we're going to do is, first off, we'll try to write down the steps. Okay, before that, what we'll do is let's try to import libraries first. So we have import CV2. Then we also need import numpy as np. Then we have import matplotlib.pyplot as plt. All right, and let's now execute this over here. Fine. Now in the first stage over here, let me give a comment. We are going to load our image. And for this, we are going to define a function. Let's say def read file. And here we're going to give the path. So let's say this name as file name. All right. And we'll have image. So this will be cv2.imread. And you just have to give a file path. And then if you want to see the image, it's going to be cv2_imshow. And we're going to pass the file name. Or what we can do is, if you want to just see the image, right, I can just use plt.imshow. Then I just have to pass this image. All right. And then we have plt.show. And finally, we should return the image. So this would return the binary part, return image. So this is all there is. So let me see. Okay, it's not going to be image, it's going to be img, right? So img. But before that, we also know that whenever the files are read using CV2, they are usually read into BGR format. We'll convert that into RGB. Okay, so we'll have image. Then we have cv2.convertColor, that is CVT color. Here we're going to pass the image that I have, that's image. Then we have cv2.color. Okay, let me just reduce. Yeah, see color. We want this for BGR to binary. Yeah, it's going to be for RGB, right? So RGB. Okay, so this looks great, and I think this should be fine. Let's save this and let's execute this over here. Cool. So now what I'll do is I'll add an image to our directory here. Let me quickly browse Google and add an image over here. All right, so as you can see here, I have loaded my image, and let's give this function call. Let's call this here, paste it here, and let's say file path or file name, right? So we'll paste this here, file name, and we'll pass a string over here. So we'll just take this, as this is in the same directory, we'll just say relative path and pass it over here. And let's try to execute this. Let's see if this works. So as you can see here, we are getting this image, right? But now I don't want to see what is this array here. So for that, the reason why we are getting this array is because I'm trying to read this image here. So if I add this to a certain name, let's say image, then we won't be seeing that part over here. So as you can see over here, this is the image which we have loaded. If you want to turn off the access, we can do that as well. plt.access, just put off over here. So if you want plt.access to be turned off, you have to use a couple of libraries, or I should say a library that is very specific to Jupyter Notebook. So for that reason, we'll just avoid this for now and just focus on this part. All right, so as you can see, our image is loading up perfectly fine. So now what we are going to do is we are going to try to create a cartoon of this. And if you're someone who's well versed with animation, you would know that, edges play a pretty huge role when it comes to cartoons, right? So what we'll do is we'll try to increase the edges of our image over here. All right, so for this, let's say mark down, and let's give a name here as create edge marks, right? So create edge mask. Fine. So what we're going to do, we have something called as adaptive threshold in OpenCV, which would help us do that. So we'll define a function here, def edge mark. All right, and this would take input as in image. Then we have line size, that is the size that you want to have for your mask, and blur value. Okay, so first off, we'll convert our image from RGB to gray. We have cv2.cvt color. First off, image, the one that we're going to pass. Then we have cv2.cv. Okay, let me just go caps color RGB to gray. All right, this looks great. And now what we'll do is we'll say gray blur. So cv2.median blur we are going to use. Pass our gray image. All right, and then also pass the blur value. Okay, and now what we'll do is we'll take the edges here. So for this we have cv2.adaptive threshold. All right, guys. So within this, this takes up a couple of parameters. The first one obviously is going to be the image. So it's going to be gray blur. So let me copy this from here. Meanwhile, let me also just change this value. All right, and let me copy this from here and paste it here. All right, and then we'll give 255. That's adaptive method, and then we also have this built-in function cv2.adaptive threshold mean. Okay, and then finally we have binary cv2.threshold binary. And then finally we have line size. This is the parameter that we are going to give out. That is the thickness of the edges. So let's give that as well, line size, and then blur value. All right, so this is all there is over here. And finally, okay, let me just drop this down so that it's easier for us to understand and follow up. All right, and now this thing will return just the edges. Okay, edges. We'll copy the edges from here. So basically what this thing is doing is this is taking in the grayscale. Let me give a comments over here. So this takes in grayscale image, and output here is going to be just the edges, right? All right, so this is what is going to happen here. Let me run this off. So as you can see, we have successfully run this, and now all we need to do is call this function. All right, we have to call this function. So let me copy this from here and paste it. All right, and now we need the line size and the blur value. So let's say line size we'll give here as 5 pixels. You can give any value that you want, and let me give for blur value also as 7 and 7. Either ways it doesn't matter. And the image over here is gonna be this one, right? So our input image. All right, so here I have done a small mistake. This is not a grayscale image, this is going to be input image. All right, we are done with this. Let me run this as well. So as you can see, this returns as one matrix. What I'm going to do is let's plot how this looks like. So let's say edges is equal to this, and let's try to plot this off. plt.imshow edges. All right, and then plt.show. So as you can see, this is what we are getting here. If you want me to enhance this, what I can do is CMAP is equal to gray. Okay, that's because we gave this as an uppercase. Let's run this again. So as you can see here, we have just the edges, right? If you want to reduce the thickness of this, it's pretty easy. We just have to change the line size. Let's say 5 pixels. And now see the thickness has reduced. All right. And we can also give CMAP is equal to binary. Now you'll see a black image with a black background. We have just white one. So even this is fine. Either ways, it doesn't matter, right? Because this is just the output that we have showing over here. Okay, so now that we have got the images, what we are going to do is reduce the color palette. So what does this color palette means? Let me scroll up. So as you can see over here, we have multiple colors here. Now what I want to do is, I don't want all of these colors. Let's say I want to focus on just just 3 colors or so. So that's what we are going to do here. Let's say, let me give a comment here. Reduce the color palette. And let me reduce this as well. Okay, so now what's going to happen, as I mentioned earlier, we just want to reduce the number of colors that we are trying to use here. So even for this, we are going to write a function that is def color quantization. And this takes in the input, that is the image. And then let's say we'll define a variable here called as K or C, any variable that you can take. And this basically refers to, how many number of colors you want to show. So first off, we'll transform the image. So first off, that will be transform the image. What this means is we'll try to reshape this off. So we'll have data is equal to np.float. And we are going to pass image here. This is going to be the input image, right? And then we'll just reshape -1, 3. Then let's determine the criteria. And here we'll have like something like CV2 dot term criteria. All right, plus CV2. So this is going to be lowercase CV2 dot term criteria max iterator. All right, and now we'll give 20 here and then 0.01. This looks great. And now finally we are going to implement here k-means clustering, right? Okay, so we have ret, then we have label, and then center. So what we'll do is cv2 dot k-means. We're going to pass data here, and then we need the number of centroids, that is k. Then we need the label, so that is none over here. Then we have the criteria that we want. Let me just copy this from here and add it here. And then we'll say 10, and then we'll have cv2 dot like random k-means, right? So cv2 dot k-means random clusters, random centers. Okay, so basically you're also trying to have a machine learning over here, part of it. All right, so now we'll have centers. Let's say center, we have center is equal to np.unit, that's unit 8, let's say, yeah. And then we'll just pass center here. All right, and finally result is equal to center, wherein I have label dot flatten and pass this off. So finally result is equal to result dot reshape image shape, and this would return the result. So that means we do not have any syntactical error as I have written this, as I've tried to execute this. All right, so now what we'll do, let's take up an image, let's say img. This will be color quantization. We will basically try to call this function. And now here k, right, we would just want number of dominant color. Let's say instead of many, we'll just give 2. Okay, this has ran successfully. Let's try to plot this up and let's see what happens. So we'll have plt.imshow. Instead of that, let's copy this from here, right? So plt.imshow, let me copy it from here and paste it. And here we won't be having binary. Instead, we'll just have image. So as you can see, we have just 2 of the most prominent colors, right? Now let's say I just want 3 colors. And now if I execute this, okay, it's not showing me here. Let's say I want 5 colors. Obviously there are different prominent colors. What happens, let's see what happens if I just give 1, right? Let's have a look into this. So as you can see, we just have 1 prominent color here. All right, so reason why we are getting this error, right? Like reason why we are not getting the changes in the color is because of my fault. What I've done is we are trying to change the color, right? And we are giving the same name over here. So what we'll do, instead of giving the same name, we'll say image quantize. All right, image quantize, and let's try to rerun everything from the start. Okay, so as you can see, now we just want to see what are the prominent two colors. Let's try to do that. Okay, so as you can see, these are the prominent two colors that we have, right? The green and the gray ones. All right, so this is all there is about, quantization of a color. So what we'll do now in the next stage, we're going to merge whatever the image that we have quantized, right? Like the limited number of images and then these boundaries. Okay, and let's see what happens. That is, let me give a comment here. Combine edge mask with the quantized color. Okay, that is quantized image over here. Okay, but before that, what we'll do is let's try to add up a filter just so that we reduce some more noise. So let me give that as a comment here. Let's say we want to reduce the noise. So in order to reduce the noise, we're going to pass this through a filter. Let's say we have this blurred, right? So BLURRED, let's say blurred. Then we have this filter CV2 dot bilateral filter. Okay, bilateral filter. And now we just have to pass the image, that is the image that has been quantized. Then we have D is equal to 7. D here is nothing but diameter of each pixel, so that's going to be 7. And then we have sigma color, so let's give this as 200. And then we have sigma space, we'll give even this as 200 over here. And now what we'll do, let's try to plot this as well. Let me get this and plot it over here. And we just need to see how this would look like. We'll copy this and paste it over here. So as you can see, our image is substantially blurred up, right? So compared to what it was over here. All right. So in the next stage, as I mentioned earlier, we are going to combine the edge mask with the quantized image, right? So we are going to combine this with our edges over here. So let's write a function for that. Okay. Instead of writing a function, we can just directly pass this through here, or you can also write the function. So, let's say def cartoon. All right. And this thing, what it would do is it takes two parameters. Okay, or let's say it would just take this blurred image parameter, right? So it would just take this parameter here, blurred, and let me paste it over here. So for this, what we are going to do is, let's say we have C, then we have CV2 dot bitwise and this would just like and up this value blurred. Let me copy this from here, and then we need mask edges, right? So we copy this, and we also have this mask, right? So mask, so this would be the edges value, and the edges value is somewhere over here on top, this value, right? So this is edges. So let me copy the edges here and let me paste it here. All right, and what this function would do is this would be like plt dot plot, sorry, it's going to be im show. We're going to show C, and then plt dot show. We'll do one thing, let's not send any parameter here, we'll just let it be the way it is. And now all we need to do is have a function call, let's say just cartoon, and let's see what this would look like. So as you can see here, we have tried to create a cartoon image of this. So let's give some more trial here. Instead of this, let's try reducing this to 3, and let me change this from K2 to 9, and let me re-execute this and let's see what happens. Okay, so as you can see here, we are getting some of the dominant other colors. And let's now see how this cartoon would look like. Yes, so as you can see here, we have tried to make cartoonified version of this, right? So let me plot this side by side. Let's also see the original image. For that, what I'll do is I'll do a small change, that is, all right, we'll try to run everything here. And finally, let's try to plot this up. Okay, so we'll also try to plot our original image. So let me copy this and write one more function. Okay, and let's execute this. So as you can see here, this is our original image. Let me zoom out. Before that, let me also give this thing here, title, plt.title, original image, and this is gonna be cartoonified image, right? So And let's try to rerun this and let's see what happens. So as you can see here, we have original image and the cartoonified image. Let's try doing this with some other images. Let me take a couple more images from Google and let's see what happens. Alright guys, so let's try to load another image. Let me just come here. We have this another image here. Let me copy the relative path and let me add this path over here. Alright, and let me run all and let's see what happens. So this is our original image. Let's see the original image and everything at the end. So let's see what happens. So as you can see here, we have tried to blur and we are trying to cartoonify, the images that we have. Well, you can do some more modifications. You can increase the thickness of your line, and that would even more enhance the look and feel of your image. So let's say I want to change this from 5, let's say 8, and even this, let's say 8, and try to run all of this from the start. Okay, the reason why we are getting this error is because we have to run this from the start, right? So let me just restart this kernel and run it all again, okay? And this value would range from 7, 7. All right, and let's try to just rerun this and run all. Okay, so as you can see here, we are getting this image. This is the original image the way it is, and then we try to cartoonify it, and this is how it would look like. Well, you can modify this in your own way, and this is just the tip of the iceberg that you can do with OpenCV. And if you have any, if you have performed any improvements, you can definitely provide your GitHub link in the comment box below. Alright guys, with this we come to the end of our session. I hope you enjoyed and learned something new. If you have any further queries, please do mention them in the comment box below. Until next time, goodbye and take care.
I hope you have enjoyed listening to this video. Please be kind enough to like it, and you can comment any of your doubts and queries, and we will reply them at the earliest. Do look out for more videos in our playlist and subscribe to Edureka channel to learn more. Happy learning!